Hey guys, it's Mrs. Chefcheck here. Today we're going to look at how we can find the slope of a line from a table. So as we know already, the slope is used to describe how steep a line is. It's the rate of change between any 2 points on a line. And we're always looking at it as a ratio of the rise, which is that vertical change, over the run, which is the horizontal. And since these form lines, the slope will always be constant. All right, and so this is kind of how we've seen it presented so far, is that the slope is the rise over the run, or the vertical change over the horizontal change. And that's going to stay exactly the same as we look at what slope, slope shows up in tables. So we can determine the slope from a table by finding the ratio of the vertical change, y, to the horizontal change. Or we can find the change in y divided by the change in x. How much is it going up or down as it's moving left and right? All right, so this table shows a linear relationship between the balance in a bank account and the number of transactions. We want to know, is it linear? And if so, what's the slope? All right, well, let's take a second to see what this table is showing us. Well, I see that our x represents our number of transactions and our y is our balance. So after there's been 3 transactions, there's $170 in this account. Well, after there's been 6 transactions, there's now only $140 in this account. So is this bank account going up or going down as the transactions are happening? Yeah, it's going down, right? Somebody's taking money out of this account. They're not putting money into it. Okay, so that means our slope is going to end up being a negative number. That's something I want to kind of keep in the back of my mind. All right, now we want to see, is it linear, and if so, what's the slope? Well, if it's linear, it's got to be increasing or decreasing at a constant rate all the way throughout. So let's see if that's happening here. So starting with my x's, my number of transactions, I'm going from 3 to 6, and that was an increase of 3. And then from 6 transactions to 9, that was an increase of 3. And from 9 to 12, that was an increase of 3. All right, well, it looks like it's going up constantly under the x, but we have to make sure it's increasing at the same rate for the y's, or decreasing. All right, so 170 to 140. Now it's going down $30. All right, and then it's going down another $30, and then it's going down another $30. Guys, what this is telling us is that every 3 transactions, this bank account balance is decreasing by $30. Somebody's taking $30 out every 3 times. All right, so yes, it looks like it is linear because it's decreasing at a constant rate. And now that we know that, we can find the slope. So we want to look at this and say, well, what is our vertical change? Well, my vertical change is what's happening to the y. So it's going down 30. And I'm writing that as a ratio with my horizontal change, which is going up by 3. And then I just have to simplify that because I know there's common factors. I can divide 3 out of the top and bottom to get a simplified ratio, which would be 10 over 1. Or I can just write it as negative 10 if I want. Either one of these would work for our slope. What does that mean for this problem? Well, it means that for each transaction, they're taking out $10. Ready for another one? Here we go. All right, so these points in the table lie on a line. The reason that's important is it's telling us that it's increasing or decreasing at a constant rate. And because of that, we can now find the slope of the line. So we want to find our vertical change over our horizontal change, or our change in y over our change in x. Well, let's see what's happening here to our x's as we're moving across our table. I'm going from -6 to -2 to 2 to 6. So are my x's getting larger or smaller as I move across? Yeah, they're getting bigger, right? The x's are actually going up by 4 every time. And I like to label that right on here to show my horizontal change, right? That's my x's. All right, and then for my y's, I'm looking and I'm saying, this looks like it's getting, this one's getting bigger. So I'm going to write that on here. From -2 to -1, it went up 1. And then here it went up 1, and here it went up another 1. And so now that we've got it labeled and we see that in fact it is a constant rate of change, we can take our y divided by our x, our change in y, I should say, over our change in x. Our y was changing by 1 as our x's were changing by 4, which means our slope is 1/4. Now it's your turn to try. Pause the video, find the slope of this line by finding the ratio of rise over run, and then push play when you're ready to check. All right, if I'm looking for my rise over my run or my change in my y over my change in x, I'm going to go like this and say, well, from here to here, from 3 to -1, what happened? Well, it went down 4. And then it went down 4 here, and then it went down 4 here. Okay, well, that looks like my change in y is -4. And then I'm going to also do the same thing for my change in x. From -1 to 2, it went up 3. And then here it went up 3 as well, and here it went up 3 as well. And so my horizontal change is a +3. And since there's nothing I can do to simplify this ratio, that is my slope. We say m equals, because that's what we use to denote slope, m equals -4/3. All right, how'd you do? All right, time to practice. If you have any questions, be sure to let your teacher know. Thanks for watching.